It's recording example 37. Usually when you're doing cubics, it's volume related. Whereas quadratics, it's area related. So here, volume because you've got 3 dimensions and hence you've got a cube. A sheet square of 10 measures 12 by 12, so it's a 12 by 12. Then 4 equal squares, x centimeters, gets removed. So this is x and that's x. You cut them out. Connect squares out. You fold those sides up, and then what you'll likely get is a little box. So if you can imagine it, these are like your folding lines. These are your folding lines. Now I fold it together, you should get something that looks like that. Okay? Now that shape there, we know that that little length that we have over here, that must be x. So the height of this little box, tin box, must be x. The question is, what is the length and the width? What's the length and width so far? So if you picture this, imagine I'm folding it. So I'm wanting to know what's that length, because that's how far this is. How do you work out that length?
Like 12 minus x.
Ooh, close.
2x.
2x, very good. So be careful. This is x here, that's also x there. And we know that the entire length is 12. So it should be 12, take away the x here and take away the x there. That's how you have this leftover bit. So that means this should be 12 minus 2x. And conveniently, because it's a square, that means this length here is also 12 minus 2x. So if I drew it in this diagram, we can say this is 12 minus 2x, and this is 12 minus 2x. So that's the first step. When you're doing these applications, that's called the modeling process. Okay, so figuring out what is the problem, what do I have? If you get this step wrong, the whole thing's wrong. So usually in your SACs and exams, we normally say show that, and would have gave you a hint. So even if you got the first bit wrong, you can still move on. Okay, so don't give up when it comes to applications just because of the first step. If you can't model it, use what they give you and carry on. Yeah? So in this case here, we now got this volume shape. They say find the values of x for which the volume is 100 cubic centimeters. Now we know that the volume formula, how do you find volume again? Volume is equal to, what's the volume of this shape? How do you find the volume of a rectangular prism-ish, flat one? What's the volume formula?
Length divided.
Yeah. Length times width times height. Our length and width, we can already see they're the same. So 12 minus 2x times 12 minus 2x, and then times the height, which is x. So I would write down 12 minus 2x times 12 minus 2x times x. And that's pretty much what I try to model up here for you here. So I have little brackets ready for you to fill in that the volume must be 12 minus 2x times 12 minus 2x. Okay, so usually in the SAC, we would have given you this line and we would have said, show that volume is this. And then you have to show us the steps. And this is called the showing process. Okay, usually in the SAC, I may have even expanded these brackets and you'd have to expand it by hand to show me. Okay, but since this is a textbook example, we now got this equation. What do you do when you get to this step? Type it into your calculator straight away. Okay, so define. Let's go. I'm going to grab out my CAS. Let's define it. Calculator. Menu 1, so menu actions, and then 1, define. F bracket x equals 2. And what was it again? X times 12 minus 2 times x times 12 minus 2 times x. You can do that. I'm just doing it so that it's familiar to you. But yes, you could have done 12 minus 2x squared, because that's exactly what it means. All right, so I would define the function. That's what I would do at any application, any problem solving. That's what we would do first. Next question. Well, actually, that question tells us volume is 100. So they're telling us this volume value is 100, and they want to find the value of x. So how much should I be cutting off to ensure that the volume of this box is going to be 100? So I'm saying, what if volume was 100? Solve for x. Now you can do this by hand. Because it's applications, you don't have to. You literally go to your CAS. We're ready to find it. This is volume. This is the x bit. So what do? Go to solve. So menu, algebra, solve. So menu 3-1. What do I solve for? I want the f of x, which we remember that's volume. What do I want the volume to equal to again? 100. So I say f of x equals 100. And what I'm saying there is I'm saying substitute v equals 100, solve for that, but it doesn't know what I'm solving for. So what do you have to put at the end? Comma x. Because you're saying solve for x when I sub in v equals 100. That's what I'm actually doing there. So in another way is it's saying solve for this when you sub v equals 100. That's your f of x. Solve for x. So instead of us doing it by hand, they'll do it for us. Okay? So here we go. Let's see what we get. Ooh. Nasty. Let's write it down. Let's interpret. Don't get scared by that, yeah? So we got x equals 1. Actually, I'll screenshot it. Ooh, let's bring this over here. Okay. So here we go. Now, that means x is equal to, based on this, we've got 1. Now, if we expand the brackets, that's negative of root 21. Negative of negative 11 is positive 11 on 2. And then this one is positive root 21 plus 11 on 2. That looks scary. Now, it depends on the question. If they ask you for find the values of x round to 2 decimal places, then you will convert that. If they say exact values, you leave it as it is. But what's a condition or limitation of x? What can't x be? It can't be negative, and it can't be 0. It's really true. So it can't be less than 0 or equal to 0. So that means we need to check, is any of these a negative number? So one way to do it on your cows, literally go back, press Control Enter. So Control Enter will give you a decimal value just to double check. Does that all make sense? And it does. You got 1, 3, and 7.7. So far, it's looking pretty good. No problems there. So to get a volume of 100, you either cut it by 3, and 1, 1. But what's the problem with 7.7? Because there is another limitation. Let's think about the sheet. It's 12 centimeters. But if I cut x with 7 centimeters, 7.7, and I cut another 7.7, what do I get left? Yeah, which doesn't make sense. So there was a limitation which was kind of hidden out of the 3 solutions. To get a volume of 100, it doesn't really make sense to have 7 centimeters and then 7 centimeters, because if I did 12 overall and you cut 7 here and 7 there, you have nothing left. The sheet wouldn't even exist. True? So even though the numbers look positive, it doesn't make sense in the application. Okay, so that's why you've got to be careful. So when you start doing these things, especially this bit here where you wrote 12 minus 2x, you have to know this has to be greater than 0. That whatever that number is, it has to be bigger than 0. It has to be positive. So if you recalculate that, let's work it out. Negative 2x needs to be greater than negative 12. Divide by negative 12 on both sides. That gives you 6. But remember, when you divide by negative, the sign switches. The condition is that x has to be less than 6. And that is how I knew 7.7 couldn't have been one of the answers. But that's what I mean. So how many students would have actually looked back and thought about the application? That's the little hint there. Okay, so that's what applications is. Just check. What are the conditions of x? And so that's why I know, even though we checked that they were all decimals and they're positive, it looked like it was all going to work, but that one is not going to work. That one's going to be too big. So 1 and 3 point something on a logical sense made sense. Well, I can prove it. I can see that 12 minus 2x, whatever that is, it needs to be a positive length. So that means x needs to be less than 6 for that to work. But we also know that x can't be a negative. So technically the restriction of x needs to be bigger than 0, but less than 6. Okay, so that is tough. I mean, how many students are analytical enough to note that bit? But that's what is expected by year 12. There'll be hidden questions like that, and then you have to be able to fix your graph to make sure that's your domain. Yeah? All right, and then part B, find the maximum volume. Here we go. How do you find the max volume? You can sketch this now and then look at between 0 and 6, because the graph can only work between 0 and 6. Find the maximum point that the graph can take. So here we go. Let's go back to our cows calculator. You've got f of x. Now if I sketch this graph, control, doc, add on a graph. If I type in f of x, this is what, actually I'll change the y values. Menu for 1, let's change the y values to, I don't know, let's do, let's try 100. Oh, not good enough. Let's do menu for 1 again. Let's change the y values to 150. All right, there we go. Now, the logic is this. Your graph, your volume cannot be negative, so you never sketch this bottom bit. Your volume graph looks like it goes all the way up and it has an x-intercept here. Now you can find that x-intercept on your CAS by going menu, analyze graph, go to 0. So you can find the x-intercept over here, click on the left, click on the right. That makes sense. We already said that the domain can only be between 0 and 6. So less than 0 makes sense. So if you want to find the maximum volume that this thing can get, this is the volume axis. This is the x length that you're cutting out. So maximum volume clearly occurs at this point. Can you see what I'm doing? So if you were to sketch this, if they asked you to sketch it, you don't sketch this bit, you don't sketch that bit, you only sketch this bit. Because logically, you couldn't have had x equals 7 or whatever it is. So that's my answer there. So let's find the maximum. Menu, 6, maximum. Click to the left of where you think the maximum is. Click to the right of where the maximum is. Now be careful. Last sack, a lot of students got this one wrong. Remember how I asked you perimeter, area, and the max length and all that? What's the max volume? 128, not 2. Yeah, so you've got to say it. So you've got to say max volume occurs at 128 meters or cubic meters. That's your max length that you can cut out. Okay, so the length that you cut out 2 centimeters on either end, that's the ideal number to get the ideal maximum volume. Okay, so that's the language you want to use. So hopefully the second time around when you do a SAC or an exam, you're more likely to be able to pick up on those little details that you didn't last time. Okay. So answering the question here, I'm just going to screenshot that. Here we go, screenshot that. And playing around with your CAS, so knowing how to adjust the graph and all that, that will be part of the skills that you must know. So Windows settings. Otherwise you can zoom in, zoom out, zoom box, zoom fit. There we go. So clearly max volume is here. So you need to write max volume is 128 cubic centimeters. So far so good? Yeah? All right, team. We're at 12:49. You can have a go with this one as well if you like, but I'm going to show you how to do it. Sometimes they'll get you to find the equation. See example 38. This is a cubic equation. You've got A, B, C, and D that you don't know. That's 4 parameters that you don't know. It means that they have to give you 4 different points to get there. And conveniently, you got 1, 2, 3, 4. How do we find this on your CAS? Very simple. Go to your CAS. Let's start again. Oh, there's also this other thing that if you don't want to go back and redo, you can add on. Where is it again? It was in here. It was doc. Insert problem. So if you haven't ever used this before, this might be nice. You know how you're doing 1.1, 1.2? That was related to the question. If you go to Documents and you go to Insert, so Documents number 4, and you do Problem, what it does is, see how it goes 2.1? What that 2.1 means is that now whatever you type, so if you retype f of x, it's just for this bit. So if you're in an exam, you could do question 1 and you move to question 2. If you wanted to go back to question 2, you don't have to start again. You just go back to 2.1 and it's all defined already. Get me? So notice how this one, f of x equals this. That's question 1. Question 2, I can now say, well, let's do define again, but I use f of x. Notice it's not bolded. I can redefine it and it's separate. It's a separate problem. That way you don't have to redefine f of x every time. So it's a nice thing to add on. So how do you get there again? Document, Insert. You click Problem. It just means you do a new problem. Everything's all reset again. And you can just start again rather than redefine everything. Yeah? So it's good for when you want to check your answers and you want to go backwards just to see how you're doing. So here in this case, I'm going to define the cubic equation. Here you're going to be careful if you're going to do this. Because we're using letters, you have to put a times in between the letters and the x's, or the variables. So it should be ax cubed plus b times x. If you don't put the times, it's not going to work. Plus c times x plus d. Make sure to put the times in between the letters. Here we go. You've got this as your equation. To solve for it, you need to sub all 4 points in. So what's a quick way of doing it? Menu 3, algebra. Solve menu 3-1. You want 4 entries. How are you going to get 4 entries? Notice the number 9. Next to number 9, there's this frequently used button. If you click on that, these are things that you can frequently use. This is the one we want. We want 4 entries. So I click on this one over here. It tells me I can put in 4 different information, or 4 or more. Yeah, so here we go. I click on this. And it asks me, how many equations do I want? Because I have 1, 2, 3, 4 unknowns, I'm going to need 4 pieces of information I'm going to put in. So you click 4, press enter. You see how I get 4 entries? Now I can type it in. Now if you look at it, the first point was when x is 0, sub 0 in for x and sub y to equal to 0. I can do it in function notation. F of 0 equals 0. This means when x equals 0, when I sub it in, the y value will equal to 0. Let's try another one. How do I type the next one? If I want to sub x equals 100 and the y is 22, what do you type in? F of, yes, that's it. So F 100. So if I sub x is 100, the result is 22. So this is saying sub x equals 100, y equals 22. That's my second equation. Let's do another one. The third one is I will take this coordinate and I sub it in here. So I'd say sub 150 in, but the result would be negative 10. So how would you just write that? F of? What would it be? F of, yes, 150 equals negative 10. So that's saying if I sub x into the equation, I get a y value of negative 10. And last one is f of 200 equals to negative 20. Now the calculator doesn't know what you're trying to solve for. They're just saying sub them in. Solve. What am I solving for? I want A, B, C, and D. I want to know what they're equal to. So here you move your cursor, make sure it's out further out, not on the bottom. Comma A, comma B, comma C, comma D. So when you're saying sub all these in, do your simultaneous equations. Tell me what A, B, C, D is. If you leave it in fraction form or exact values, you should get fractions. If you didn't change your settings, you would have decimals. So you either have what I have there, or you have the decimal version. Okay, it's likely that you'll need it in the exact value. And that answers the first part of the question. What is the cubic equation? A is equal to 19 on 375,000. plus b, which is negative 23 over 1,250 x squared plus 233 on 150x and d, which is, what is this? 0. Oh, d is 0. Oh, that's it. There you go. So now I've got my equation. Is it 233? Yeah, 233. I'm just going to fix my handwriting. 150, 233, 1,250, and that's 375,000. There we go. ABC, find the maximum deviation of the graph from the x-axis. They're really just asking what is the maximum length from the maximum point to the x-axis. How high is that? Or how far is that? Which one has the greatest value? So how do you do that? Graph it and then find maximum minimum. So here we go. Now, what's a quick way of telling it to graph on your CAS instead of typing all of this again? Here's a quick way. Go all the way up. So highlight, press up and down. Press up and down on your cursor. See that one says define, so we're going to redefine it. We're going to press enter, bring it down. Go to control equals. See that vertical line? That means given. Go to given, and then all you have to do is copy the answer that you had. So you say given that A equals this, and B equals this, and C equals this, and D equals this, you'll automatically know that A, B, and C equals that, and you don't have to type it again. Okay, so if I just copy that, press enter, this is what it looks like. So I'm saying define this given, and I just copied the answer for A, B, C, and D. Press enter. Okay, so that instead of me substituting A again, and B, and C, and D, it does it for me. It saves me time instead of typing it again. So now I can go to my graph, go control, page, graphs, and if I type f of x now, oh, why is there a slider? That's not right. Didn't it? I thought I defined it already. That's weird. Whoops. Let me do that again. Let's do it again. Control, page, graph. Yeah, I don't know what happened before. You should be able to get the graph without the slider. I don't know why the sliders came up. Menu 6, maximum. I just retyped it again. But it should have just worked in the first step. I don't know why the slider. Did the sliders come up for you? Are you able to press cancel? Otherwise, make a new graph again. So do control page, add on the graph, and then type f of x again. It should come up without the sliders. Still got the sliders. I just realized I can't seem to find the maximum of this one. Oh, I need to play around with this a bit. Somehow it's not working on my end.